This is Math 139, and we're working in section 4.10, talking about how to graph square root functions. Like we usually do when we start a new kind of graphing, we'll begin by simply plotting some points and seeing what this thing looks like. So, let's see here. I'm going to make myself a little table of values. And since the function f of x is just the square root of x, to make my life a little bit easier, I'm only going to pick x values that have nice square roots that I can do in my head. Of course, I can't consider any negatives because we can't graph imaginary numbers. So we'll start with 0. Square root of 0 is 0. 1. Square root of 1 is 1. And then I'm going to skip to 4 because that's the next number that has a nice square root of 2. 9 would have a square root of 3. 16 would have a square root of 4. And that gets us as far as we can reach on the x-axis that we have provided, so we'll stop there. And then I'm just going to go ahead and graph those points. So 0, 0, 1, 1, 4, 2, 9, 3, and 16, 4. And if I just kind of join those, I get my graph. All right, what is the domain of this function? Well, we already talked a little bit about that when I mentioned before that I can't put a negative number under the square root unless I'm going to allow imaginary answers, which would not appear in my graph. So the domain really is just x is greater than or equal to 0. And you can see that in the graph as well. In interval notation, I can write that as the interval from 0 to infinity. What about the range? Well, if you look at the graph, the smallest y value on the graph is also 0. And those y values continue to get bigger and bigger, slowly, but they will continue to go up. So I'm going to say the range is also from 0 to infinity. When you start thinking about how to graph transformations of this function, probably the one point that you really want to make sure you have in the right spot is this point right here. Usually we call that the initial point where the graph starts. In this graph, the initial point is 0, 0. But when I do transformations, I'll usually make sure that I shift that initial point and get it in the right spot. And then maybe add an extra point or two to get the rest of the graph shaped correctly. So let's look at a few examples of transformations of this type of graph. All right. So, g of x here is the square root of x minus 3 plus 2. And I'll note that this graph would be shifted to the right 3 and up 2. So going from 0, 0, which was the initial point, and moving right 3 and up 2, there's my new initial point. Now I can already tell, basically, that graph's going to have that same square root curve, starting from the point 3, 2, the initial point. All right, in order to get the shape of the graph a little bit better than I could do if I just drew from here, in addition to that point 3, 2 that we already have, I usually try to get a couple of other what I'll call convenient points, points that are going to come out nicely when I substitute them into my function. So just as a reminder, y is the square root of x minus 3 plus 2. And I'm going to notice that if I were to put, say, 4 in here, 4 minus 3 is 1, and the square root comes out really well. So plugging in 4, that's going to give me 1 plus 2, or 3. Let's think of one more point that would be convenient. For example, 12 would work well. 12 minus 3 is 9, and I know how to take the square root of 9. So let's pick 12. So the square root of 9 is 3, plus 2 would give me 5. Now, there are other convenient points as well. Those are just the ones I happen to pick. So if you pick different ones, that's okay. But let's get these on here. 4, 3, and 12, 5. Okay. By using those as just sort of guidelines and remembering what that basic shape of the square root curve looked like, I can get a pretty decent graph just by sketching it in from there. The domain of this particular one, all the x values are 3 or larger. So from 3 to infinity. Notice I do include the 3, right? That graph does hit that point at 3, 2. And for the range, 2 is the smallest y value. So the y values go from 2 to infinity. Again, including the 2. I'm using a hard bracket there. Oops, you can't see that. There we go. So from 2 to infinity. All right, let's try a couple more graphs. In example 2, I see a negative out in front, which is going to turn this upside down or reflect it across the x-axis. And then also this plus 1 here is going to shift us left 1. So going from 0, 0, I move left 1. There's my initial point at negative 1, 0. And then it's going to be reflected across the x-axis, so I'm expecting it to be down here. We'll get a couple of convenient points to help us get the graph in the correct spot, but we already kind of know what it's going to look like. So negative 1, 0 was my first convenient point. That's an important one. That's the initial point. And then we'll go ahead and say, remember that our equation was y is equal to negative square root of x plus 1. And again, I want to pick some nice convenient points in here. 3 might be a convenient point. That'll give me the square root of 4, which I can do. So negative square root 4, it's negative 2. And let's see, what if we also use 8? That will give me the square root of 9, which is also a nice value. So that would be negative square root 9 or negative 3. All right. Plotting these points then, we had 3, negative 2, and 8, negative 3. And again, I'm just going to sketch in the upside down version of the square root curve, making sure to hit those 2 points. And it'll look something like that. For my domain, all of the x values are bigger than negative 1, so my domain goes from negative 1 to infinity. And for the range, 0 is actually the largest y value, so my y values go from negative infinity up to 0. Once again, that initial point is a point on the graph, which is why I've used the brackets on those ends. All right, we're going to take a look at one more. In example 3, I have 3 times the square root of x minus 5. And as far as transformations, that 3 is going to be a vertical multiplier, or excuse me, it's a multiplier. So it's going to be, it's going to make it taller, right? Taller and skinnier. And then the 5 is going to shift us down 5. So let's see, we've got a vertical stretch. By a factor of 3. And then we also have a down 5. All right, the down 5, starting from 0, 0 again, and just going down 5, is going to move the initial point right here to 0, negative 5. And I'll start with that as my first convenient point, the initial point. Then remembering that y is 3 times the square root of x minus 5. I'd like to come up with 2 more convenient points that I can use. And all I have to be able to do is plug them in here. So I'm going to go ahead and use 1. 3 times 1 is 1. 1 minus 5 would be negative 2. And let's see, let's go with 9. 3 times the square root of 9 minus 5 is 3 times 3 minus 5. 9 minus 5 would be 4. So we're going to end up with a point at 1, negative 2. And then another point at 9, 4. And it'll still have that same basic square root curve, but notice it's a lot steeper this time, and that's that vertical stretch, that factor of 3. All right, as far as the domain, the x's are greater than or equal to 0, so from 0 to infinity. And the y values, negative 5 is actually the smallest y value, so we would go from negative 5 to infinity. All right, so that's section 4.10 on graphing these square root functions.